Hello, Joe Marzillo here with another technical video. This time the subject will be crossbow arrows. And on a vertical bow, we would measure a number of things. We measure the length, we would measure diameter, we would measure the spine, and then we measure the speed of the bow. We measure a lot of things. And we'd know those things so that we can apply that knowledge to other bows or other setups. Now, for whatever the reason, crossbow arrows haven't been treated in the same way. They seem to be treated like some mysterious creature, which it's not. It's an arrow. This is an arrow, that's an arrow. What we don't know about a crossbow arrow is its spine. We can measure the weight, we can measure the length. We can measure the speed, but we can't measure the spine, and I think that's ridiculous. We should have that information. And so to that end, what I've done, I've created a piece of equipment to measure crossbow arrow spine, so you can compare one arrow to another and understand or have an expectation of performance when you change it. So we're going to take a look at that and look at a piece of equipment I designed to measure the arrow spine. And you'll see that it's very, very similar to any other vertical bow arrow that you have experienced in your life, and you know what happens when you change spine with arrows. If they're too limber or too stiff, you'll get better or worse performance. So let's take a look at that. So here we are, we're looking at a arrow spine fixture that I designed some years ago, but it's designed to take 24-inch span instead of the 28-inch span. Reason being is if you want to check an existing arrow, there's very few people shooting a 28 or better inch arrow today. It's all less. So this fixture was designed with a span of 24 inches, the same load, and then the deflections are calculated to give the same thing as if it were 28 inches. I did some of the calculations myself, and then I verified it by using a very fine program. Archer's Advantage, a fellow from California, Perry Radcliffe, developed it. He's a smart guy, and I highly recommend Archer's Advantage to anyone. It's an awesome program. So let's take a look at what we can do. What I did is I have a 300 spine arrow. I'm going to check it first on my fixture, and then we're going to go over to the crossbow arrow fixture, and we should get the same result. Okay, so here's an arrow placed on this fixture, and we can see that it's zeroed. When the arrow's all the way down, it's zeroed, and we're going to apply the load of 1.94 pounds, which is 880 grams. And we have right there 200 thousandths in deflection. That's pretty close to a average 300 spine arrow. So from here we're going to go over to the fixture that I built and designed for crossbow arrows. Okay, we're at a special fixture that I designed and built for checking crossbow arrows. It's a 16-inch span, and the load will be 10 pounds, and this will give you very accurate spine readings that are comparable to any arrow shaft that you did, no matter what the method. I like 16 inches because I can check the vast spectrum of crossbow arrows. So here is the arrow. Let's see if it's zeroed. It's pretty close. A little bit more. Okay. There we go. Close enough. Zero. And we're going to put 10 pounds load on it. We'll see how much deflection we get. But we just passed 100 thousandths, and we're going to go to 200 thousandths, and here we are, 290 thousandths, and that's exactly what I measured before. It's a gold tip. Let's see which one it was. Ooh, 290 thousandths, gold tip ballistic. So this has a 290,000 spine. So I've checked all of the arrows using the same methodology, and you'll see when you look at the chart that there's a lot of arrows that have a very, very similar deflection. 200,000 down the road. Then they start to get a little bit weaker, a little bit weaker, a little bit weaker until you find the very weakest arrow. So what does that mean to you? That means that you can use a pretty wide spectrum of arrows, and assuming that they're fletched in a similar way. For instance, you need the same distance from the nock to the beginning of the fletch to provide clearance when it goes into the trigger mechanism on an arrow. You have to have the correct kind of nock. You have a nock with a V capture for the string, or a flat. Some bows would want you to use a flat, but I think this makes a heck of a lot more sense. But anyhow, so there you have it. That's what this crossbow arrow needs to look like. And what else does it need? It needs a specific diameter of around 345 thousandths. Reason being is, just by this little drawing, this would be the crossbow rail. There the arrow fits in there, and there's the string. The string wants to be somewhere near the center of the arrow for sure, and it doesn't want to be small enough to slip in between the rails. So it's not critical, but it's important. 345 thousandths. That's what I've found is a nominal dimension for all the arrows that I've checked to date. All right, let's take a quick look at the chart, and you'll see there's a number of arrows from different crossbow manufacturers, from Barnett, Beeman, Raven, Excalibur, Headhunter, Gold Tip, XO, X, Striker, blah, blah, blah. I don't know. Anyhow, but the important thing to recognize is that most of them are around the spine of 200 thousandths. Then they get a little bit more limber as you go up until you get to the most flexible one. It was this Easton Magnum. It's a 344, 325 spine. The diameters are all virtually the same. Okay. Let's take a look at this chart as well. And you can see graphically how the arrow's spine changes just by the bar chart. It's pretty self-explanatory. The higher the bar, the more flexible it becomes. So for the most part, if you look from this arrow down, they're all, performance-wise, are going to be the same. This is all static spine. It's not dynamic spine. The difference is, like it indicates, static is not shot out of the bow. Just put a load on a specific span, and you get a deflection. Dynamic spine is when it's shot out of the bow, and depending on the weight of the head in front, you're going to get more or less bending moment as it goes through acceleration. The arrow's doing this more or less as the arrow becomes stiffer. So that's an important consideration. But also it indicates that you can use a lot of different arrows. There's nothing special or magic about one manufacturer's arrow than the other if you know the spine, and currently you don't know the spine through the manufacturers. There seems to be no standard from what I can understand, but the standard is kind of easy to do. I just did it. It's 16 inches. The span with a 10-pound load will give you the same deflection as if it were an arrow being measured at 28 inches with a 1.94 load. You'll get the same results. So I endorse going this way, and I hope the manufacturers will pick this up and start checking your arrows and supplying that information to you, the end user. The charts will be available to you at the end of the video. I'll show them for quite a long time, so you can take a screenshot of this and print it so you can have it for reference. I haven't figured out a way to make a downloadable file on YouTube. If anybody out there knows how to do it, please contact me. I'd be glad to do it. One of the other things that we should look at is the FOC on the arrows. FOC can change dramatically with point weight. If you take a look at, just for an example, this Headhunter arrow, and with a 125 grain point, it's a 14% FOC. With a 100 grain point, it's 12%. That's a big difference. To me, it's well worth it to go with a heavier weight point. What's important to recognize also is how I calculate FOC. There's different ways of looking at it. Some people say you should measure from here to the knock of the arrow, and then that determines FOC. I disagree with that. When you measure the balance of the arrow, which is center of gravity, you do it measuring the whole arrow, the point, the knock, everything. I don't know why the center of the arrow disappears when you're trying to develop a FOC number. So my calculation says the entire length of the arrow, from the point to the knock, and then it's calculated as it's shown, and it gives you a very accurate representation of what it's going to do. So for you folks that are trying to understand this, if you do it that way, I believe you'll come up with an accurate result. And there's the easiest way to get the balance point. A little piece of string, move it along your arrow until you get this, put a mark on it, and then that's your balance point, or center of gravity, or that'll be your FOC point, but not the calculation.